Welcome to The Explainer. Today we're diving into what might be the single biggest debate happening in AI right now. It's this fundamental question about prediction versus actual understanding. And honestly, the answer could change, well, everything.
So let's kick things off with a little bit of a mystery. It comes from a recent Harvard study, and it poses a really interesting question. Can a machine be 100% perfect at a task, while at the same time having absolutely zero clue what it's doing? Well, it turns out the answer is a big, flashing yes.
And here's where it gets wild. Researchers trained an AI on 10 million, that's right, 10 million simulated solar systems, and it got flawless at predicting where the planets would go, 100% accuracy. But then they asked it a simple question about the force making it all happen, gravity. And the AI had no idea, zero understanding. It learned to predict, but it learned absolutely nothing about physics. This whole paradox points to a massive crack in the foundation of modern AI. It's a problem researchers have started calling the pattern matching trap, and it all comes down to something called inductive bias. You see, the AIs we're building today, they're just hardwired to memorize statistical patterns. They're not built to discover the deep, universal principles that actually run the world.
Here's a great way to think about it. The AI didn't learn physics, F equals ma and all that. No. It just learned that when this string of numbers shows up, it's usually followed by that string of numbers. It was basically playing a game of connect the dots, but it had no idea what picture it was supposed to be making.
And look, this isn't just some dusty academic debate. One of the godfathers of modern AI, Yann LeCun, who runs AI at Meta, dropped this bombshell. He thinks this exact flaw, this pattern matching trap, makes the entire way we're building AI today a complete dead end. In fact, he's gone even further. He's basically told the thousands and thousands of brilliant people working on large language models that they're on the wrong path. He argues that the transformer architecture, the engine behind things like ChatGPT, has a hard ceiling. It will never, ever get us to true human-like intelligence. That's a pretty big statement.
And you've probably seen the signs of this trap yourself, even if you didn't have a name for it. It's when an AI playing Othello makes a perfectly legal move, but on a version of the board that only exists in its own head. Or when an AI video generator creates this stunning, beautiful scene, but the water is flowing uphill. Or, when ChatGPT spits out code that looks perfect, the syntax is flawless, but has a simple logical error that makes the whole thing crash. These aren't just random bugs. They're all symptoms of a system that can only mimic, not understand.
Okay, so all of this has brought the entire field of AI to a major crossroads. Right now, there are basically three competing philosophies, three big bets on how we should go about building a machine that can actually think.
So here are the three big bets on the table. First, there's scaling. This is the one we see everywhere today. The idea is simple. Just keep building bigger models and feeding them more data, and eventually, true intelligence will just emerge. The second bet is test time compute. This is more about giving the models we already have more time to think through a problem. But the third path, world models, is totally different. It's about throwing out the old playbook and building a whole new kind of AI from the ground up.
So let's dig into that third path for a minute, because it really is the most revolutionary idea. People like Yann LeCun think this could be the real breakthrough. And it's all built around this concept of a world model.
The funny thing is, the idea of a world model is something you already use every single day. Think about catching a baseball. Your brain isn't sitting there solving a bunch of complex differential equations. Nope. It's running a quick and dirty physics simulation in your head to guess where the ball's going to be. That intuitive simulation, that is a world model. So, to put it a little more formally, a world model isn't just looking for patterns in data it's already seen. It's actually building its own internal, working model of how the world works. It understands cause and effect. It gets physics. It learns the rules of the game of reality itself. So how would you even build one? Well, a blueprint from a few years back breaks it into three parts. First, a vision module takes in what the AI sees. Second, and this is the key part, a memory module runs little simulations. It essentially daydreams about what might happen next. And finally, a controller looks at those simulations and picks the best action. The result? An AI that can actually plan ahead.
instead of just reacting to what's in front of it.
And make no mistake, this isn't just a theory anymore. There's a huge strategic game being played behind the scenes. Even companies that basically invented the scaling approach, like Google's DeepMind, are hedging their bets. Word is, they're quietly putting together one of the biggest research teams on the planet dedicated to world models. They're getting ready for a future where today's AI might be irrelevant.
So when you boil it all down, this entire massive debate comes down to a single question. What really separates human intelligence from the artificial kind we have now?
Humans, we're amazing at generalizing. A little kid sees an apple fall, and pretty soon they just get that the same rule, gravity, applies to everything, from a thrown ball to the moon. But today's AI, it just gets stuck. That solar system AI memorized millions and millions of patterns, but it never ever had that aha moment and realized they were all caused by the exact same single rule.
Now, this quest for understanding isn't just about building a smarter AI. It's also about building a safer one. Think about it. An AI with a true world model might finally solve the hallucination problem because its answers would be grounded in reality. It would have actual common sense. And maybe most important of all, we could look inside that model and see why it made a decision, instead of just staring at a mysterious black box.
And this is what makes the whole thing so incredibly high stakes. Right now, there are billions upon billions of dollars being poured into scaling up the AI we currently have. But if Yann LeCun and the other world model folks are right, all of that cash, all of that effort, could be going into a technological dead end.
Ultimately, the path that the AI industry decides to take is going to answer a really fundamental question. Are we building a true partner in thought, a machine that can actually understand the world with us? Or are we just getting really, really good at building an incredibly sophisticated parrot, one that can mimic our words perfectly, but with absolutely nothing going on behind the eyes? The next few years are going to be very interesting.